So we have a quadrilateral inscribed in a circle, and the diameter of K is 20. So let's say this here is 20. What that also means is that the radius, because K is the center of the circle, we can then determine, I need a different color here, that this is 10 and that this is 10. And AC is perpendicular to BD, so these are right angles. Again, to determine the area of ABCD, basically we could if we could find the area of each of these triangles, which is 1/2 the base times the height, or 1/2 the base, which is CA, times the height, which will be ED and BD, the sum of those two triangles' areas will be the area of the quadrilateral. So if we can get that, we're set. Anyway, let's take a look at those statements. Statement 1 tells us that AB equals AD. So that gives us these two dimensions as being equal, which would be useful because then we could just find perhaps the area of one of the two triangles, and then double it. But on its own, we don't have any measures. So on its own, statement 1 can't be sufficient. We cross off A and D. Statement 2 tells us that the length of CE is 8. So if CE, this length, is 8, then EK, I'm running out of colors here, EK here is 2. The reason that's handy is then we could actually draw a third triangle in here. Once we can figure out what ED is, we have a much easier time. I should color this in the rest of the way. And we know that KB is also the radius of the circle. So we made this triangle. We have one base, one side which is 2. BK is a radius of the circle, which we've already established is 10. From here we could use the Pythagorean theorem. 2 squared plus whatever this side is squared will equal 10 squared. We'll call it x. So 2 squared plus x squared equals 100. X squared plus 4 equals 100. Therefore, x squared equals 96, and x equals the square root of 96. We don't even really have to figure out any more than that. That's the height of the triangle. We know the base of the triangle. We know that the two are equal. So from this, we can actually figure out the area of each of the triangles ABC and ADC. So statement 2 is sufficient. Answer choice B.